I have shown you this sign in my road trip video. It used to be a flasher with a large original current coil transformer with some flashing mechanics in it, and somebody converted it to a European electronic transformer, maybe just to operate it in Europe, or maybe because the large one is dead. I don't know, but I'm about to find out today. This 4K electronic transformer is too small for the sign anyway. It's making a high-pitched noise. I think it's just heavily overloaded. This looks rather like an 8K or 9K sign to me. So I'm now gonna take the thing apart, open that original transformer up. The wires have been cut, so I don't know if I can save anything, but we're about to see. The transformer label says it has two secondaries with one end grounded, a 5000 and a 3000. So I think that this interesting T piece here, that looks to be made of glass, was where the common ground was connected. And then on this wire here, the border tube was flashing, maybe on the on the 3K windings. And on this point, the white text was fed on the 5K windings. So now I'll take off that electronic transformer that is just mounted with cable ties anyway. It came out of the connector just by pulling. That GTO looks really old. It looks like it has some fabric in the insulation. Some kind of fabric reinforced sleeve. Okay, this one is gone. And now I'm going to unmount this huge and heavy transformer, and we're going to open the case. Wow, it's really heavy. It's gonna smash my hand. Crazy. It even has porcelain insulators. Oh, they are broken. Okay. The lid is glued with silicone. I'm not sure if that's original. I think somebody might have been inside this before. Oh, okay. This, I think, is not what it should look like. Well, I haven't seen a hole like this in a tarmac potted transformer, but I think it has failed and burned up here from the traces. This hole here doesn't look normal to me, so either it failed in its regular life, or some idiot connected it to the German 230 volt grid, although it was 110, and that just made it burn up. I'll now try to get a power cord and a multimeter Maybe I can measure out something to get some further information if this is still okay or not. Okay, so this white wire should be the common ground for the both primary windings, and then red and black is the two transformer parts. So I'm now going to measure neutral to this first transformer, primary, and that is a possible value, single digit ohms. That could be correct. And the same for the other wire. And that's pretty low. So maybe the red transformer had a ground fault from the winding to the core or something like that. Now I'll try to measure if I can get anything out of the secondary windings that makes sense. So I'm bringing this probe to the case ground. Okay, and now one of these high voltage taps should be ground. I think it's that one, and then these should read some kilo ohms of the high voltage windings. That could be alright. And there is nothing here. Nothing here. No. Well, it'll be hard to say what really happened. So either the primary or the secondary winding just burned up. But this chaser unit is pretty cool. Cynotrol. I think they also made flashers and chasers for larger neon signs. I think the Neon Preservation channel has a review of an old Cynotrol flasher. And it looks pretty clean. You see there's these cams that rotate. The motor drives them, and those little switches open and close. Okay, I don't think I can save anything on this transformer. I will maybe try to get it out of the metal can and fit two small electronic transformers inside the can just to keep the original look of the sign. I'm using a wood chisel and a hammer to try to get the potting out of the can. I've done that successfully before on an Eggtown transformer that had a resin potting, but this one is tarmac now. It had an interesting smell, by the way, like a mixture of old car coal and old oil or something. And those little pieces of tarmac were really sticky on my hands and on the floor plate, so be careful where you do this work. So I'm just hammering all my way around the edges to separate it from the sheet metal wall. I'm speeding the video up a bit. Some people unpot tarmac potted transformers with heat by putting it in an oven or even in a fire. That's not for me. I think that's crazy. Okay, the first transformer core starts moving now. You can see it come out just a bit. And this slamming it down on a piece of wood already did it on the Eggtown that was resin potted, so I'm trying that here. And we have some more movement, but still not enough. How you like my shoes and my socks? And looks like we're getting closer. Come on, man. Here we go. So this is one of the two transformers. They might have had the same core size and just different windings, turn amounts. And you see the red wire on top. So this is the red wire that we measured with the low resistance across the winding. So I guess this is the transformer that failed. And also where my finger is right now, there is no tarmac, so it looks like this winding got hot and the tarmac flowed out of it. It's really just an open core transformer submerged in tarmac. And the second one is out, so I'm now trying to get some more tarmac out with a wood chisel and clean the tarmac on the outside with alcohol. And then this is what it looked like. On the rest of the bit of tarmac pieces, I just spray painted the inside to make it look nicer and seal the smell in. And I put some cable bushings on the top. I'll talk about that later on. And here's the top view, so it will need just a bit of paint touch-up around the right side of those cable glands. Now I put both the electronic transformer into the case on this wooden spacer at the bottom. And I used some old plastic pens to extend the setting knobs for the dimmer and the flasher to outside of the case. So here's a plastic pen and here's the other. The left transformer is the flashing one, the right is just the dimmable one. Here are all the wires. I kept the original pull switch and I'm about to test run the transformer now. And this is how the cable glands look like. I used sawed-off plastic cable glands just to have a protective bushing through the sharp sheet metal housing. And I have some bad news. I broke the sign. I had unmounted this border tube because it was tied with copper wire and it needs a non-conductive wire and also needs non-conductive spacers. And I forgot that I had just loosely placed it on the frame, so when I lifted it up it fell down and broke into several pieces. So I have to see if I just connect here and finish it up again or make a completely new one. But anyway, I'm set up to do a test run. I have connected the text tubing to this transformer and a dummy load instead of the frame to the flashing transformer. So let's pull the switch, see what happens. It looks alright. Okay, there's no buzzing. And this should be the knob for the flashing speed. Yeah. Oh, it might, that's smart. I think they designed this transformer in that way that when you turn the flashing speed all the way down, it goes to steady on, so you can run the sign in steady on when you don't want the flashing. That's cool. The Hansen transformers have an external switch for that. So a wire is going out with two cores, and when you switch them open or closed, you can start or stop the flashing. But looks like Technolux made this on the 0 position, it's steady, and then when you turn it up, it raises the speed of the flashing. Yeah, that's cool. And I forgot I have a new toy that I want to show you. I'll get that real quick. Speaking of the German transformer, electronic transformer manufacturer Hansen, I remembered I found this thing. It's a milliamp meter and it has a few cool features. It works on regular current coil as well as on electronic transformers. According to the data sheet, it's true RMS measuring, so it will measure the correct current even on distorted waveforms like when the sign is dimmed. And to make it even cooler than that, they made it power itself from the neon circuit, so it doesn't have a battery. So now I'll get it in the circuit loop to measure some currents. I don't know if you can read that on the video, so we have around 18 milliamps going through the text right now, and let me turn the dimmer and see what happens. We're at 10 milliamps now, and the minimum, oh okay, it goes off on the minimum setting. So at around 7 milliamp it starts to work actually. When I turn it down more, 6 milliamp, 5, now it's pulsating and not working correctly anymore. Germany is a typical cold cathode and thick diameters country, so usual currents for neon would be like 20 to 100 milliamp, so that's why maybe they didn't design it to work below 6 milliamp. But it's a cool toy anyway, just to find out how much power you're giving a sign, for example in dimmed condition compared to the full power. Alright, back to 18 milliamps. So that's it for today. No finalizing of the sign. I've just ordered gray heat shrink tubing to slide over these cables so they match the gray frame and the gray blockout paint. And then when I have repaired the clear glass frame, I can put it all together. The repaired border tube is back from processing, and I have painted the blockout paint to the electrode area and mounted it into the sign. So this is how the sign looks from the back now. This is not an ideal way to mount wires from an electronic transformer. I can do it like this here, so close to the metal, because the border tube has a separate transformer and it's maybe running on only 2 kV or so, and the electric fields that go coupled to ground in areas like these get worse the higher the voltage is. So with 2 kV this should be alright. This is a difficult sign to retrofit with an electronic transformer anyway, because this reflector is metal on the older versions and then metallized plastic on the newer versions, and it will always act as an antenna to catch the electric fields of the tube that is supplied by an electronic transformer. So I try to improve the spacing by using these pieces of silicone GTO insulation, and then I used this non-conductive nylon fishing wire and a crimp ferrule on the back side. And also I used a bit of clear silicone glue to glue the tubes to these spacers, so I hope that'll be alright. This is the best you can do with these reflectors. The best thing would be to retrofit a magnetic transformer, core and coil, but I couldn't do that in this case. So let's power it up. Thanks for watching. Please come back to the channel for more neon sign stuff.